What up, everybody? Welcome to another episode of Ask Paul. My name is Paul Abernathy, your host, and welcome to the podcast. If you've never been here before and this is your first time, thanks for joining me. How about a thumbs up and share it with other people, and be sure to subscribe to whatever channel you're listening on, whatever platform you're listening on. We appreciate you taking the time out of your day to join me. If you want to have your questions answered and you have questions about the National Electrical Code or electrical installation in general, do me a favor. Go over to our website, www.paulabernathy.com. That's PaulAbernathy.com. And there we have a portal that you can put your name in and put your question in, and it will come directly to me, and I will be able to filter out your questions and either answer it via email, or you may be one of the lucky few that get your question answered in a podcast like today's episode. If you want to listen to more shows on electrical, then check out the Electrician Live broadcast network. It's got multiple shows on there, whether it's our Electrify, which is kind of a Joe Rogan-esque type of thing where you can watch the video and listen to the podcast. That's called Electrify, so that's what that channel is. Or you can listen to the Ask Pauls from there, or you can also listen to the Master the NEC or watch certain videos from there as well, over at electricianlive.com. So that is going to be moving forward. Our broadcast network, we're going to have other educators, other providers will be sharing their shows on that platform coming up in the near future. So again, it's trying to create a one-stop shop for education and learning and interesting podcasts and videos and all those type of things. So remember that, electricianlive.com, bookmark it, and that's where you're going to go to get to the channels for electrical trade content. Okay? All right, then again, all of this is sponsored by Electrical Code Academy Incorporated. And if you want to get your Electrify swag, you want to get some goodies, you want to get some hats, some shirts, mugs, whatever you want, go to Electrician Pride. That's Electrician Pride, PRIDE.com. And that is our official website for all of our swag and our goodies and our shirts and sweaters and hoodies and whatever is over there. Check it out. Some stickers, the new Electrify stickers are pretty cool to put on your work hat, your hard hat. So check that out. We do appreciate all the patronage that you give us. Okay, so today's episode is a question, and this is a long question. So I will do my best to try to answer this question. And as I always say, if you're the submitter of a question and you do not feel like I answered your question, that's okay. I'm doing my best. I'm trying to convey it in an audible way. There's other people out there that say, well, I could do it better. Well, I eagerly encourage them to create podcasts and do videos and do a better job. That's perfectly fine. That's the platform. I'm doing the best I can. So, I'm maybe not the sharpest tool in the shed, but I do my best. So make sure you submit it. And if you submitted this and you want to follow up, just go back to paulabernathy.com and submit a follow-up and give me a little more detail. And I'll try to answer it a little more detail. Okay, so today's question comes in, and it is a long one, so bear with me. He says, "Hi, Paul. Sorry, this is a long one." Okay. He says, "My question is regards to the practice of including an equipment grounding conductor or bonding jumper in a metal service raceway along with the service conductors." Okay, so that's the first part of it. Now, what I will generally tell him that typically what we might be talking about is from the back of the panel through to a meter. Of course, now you have to have a 1 and 2 family. You have to have an exterior emergency disconnect. But anyway, to keep it simple. So he's saying installing equipment grounds or bonding jumpers in a metallic service raceway between, let's say, the panel and an outside meter. I will tell you anyway that this is I'm going to go deeper here, but this is a common practice. If you use a metal raceway and you're running grounded conductors, and the nature of how everything is bonded at the service, you're going to have parallel paths, whether you like it or not. Theoretically, the code says you have to do something to remove those issues, but it is a very common practice, and we do it all the time. And I don't know of anybody that would turn it down. And basically, to get rid of this, you would run PVC between it. I mean, that's the only way to do that, okay? So metal raceway between the service panel and a meter outside, plus you're running, and since the main bonding jumper is in the panel, So if you were doing that in the way you're going to bond at least one end of that raceway between the panel and the meter, theoretically you're creating parallel paths. Okay, so just kind of keep that thought in your mind. But that is a consequence that's pretty common, and us on the code panel on Code Panel 5 have talked about this, especially when we try to define objectionable current, realizing there were other areas in the code which we're going to tell you to do something that could create objectionable current, but it's okay because of what the code allows you to do. So it became a trickery slope for us to be able to define it. So ultimately, we did not define objectionable current. And for those out there that say it's easy to define, where the heck have you been? Please submit your public input. Now you're going to have to wait till 2026, smarty pants. But we could not collectively, because of other areas that the code allows you to do certain things, that you could create something like a parallel objectionable currents. And so we had to really think about how do we define objectionable currents, and we really couldn't. We're going to leave that up to what the code says and in your interpretation of that. Anyway, so that's kind of setting the tone of what the question's coming. I'll also remind you that those typically are not be equipment grounding conductors that would go back through that raceway because it is on the line side. So typically, I don't know of any equipment grounded conductors that would go through there, but you wouldn't want any equipment grounded conductors going through there, especially from the service equipment, because again, it is intimately connected to the grounded conductor through the bus, through the main bonding jumper, to the metal enclosure and all that. So yes, that obviously would be something you would not want to route your equipment grounds through. Plus, you want to route your equipment ground with your circuit conductors. Okay, so typically you wouldn't separate it like that anyway. So I think it's just terminology, because he does say bonding jumper, but you could potentially have somebody run a supply side bonding jumper through and take it to the meter enclosure or something like that, which again, due to the nature of how the connections are made in the service equipment, does create multiple paths for potential neutral conductor current to travel. It does. Okay. It is what it is. Okay. So let's kind of go on a little bit deeper here. So his question goes on to say, in my understanding of the code, I believe that 250.6 requires us to arrange our wiring in a way that prevents objectionable current. Okay, that is true. I mean, what does it say? It says 250.6a says arrangement to prevent objectionable current. It says the grounding of electrical systems, circuit conductors, surge arresters, surge protected devices, and conductive, normally non-current carrying metal parts of equipment shall be installed and arranged in a manner that will prevent objectionable current. I'll agree with that. That should be the effort anyway. Okay, so I'll agree with that so far. It says a parallel path for neutral current provided by an EGC size smaller than 1/0, and the service conductors would be a violation of this requirement. Yes. So again, I don't necessarily think that anybody's going to put an EGC through there, equipment grounding conductor. You might have a supply side bonding jumper run through there. You might have somebody run a grounding electrode conductor through there to get out and then come down because they're going out instead of poking its own hole out. They try to do that. You could get those, but I don't necessarily think that you're going to have EGCs doing this. So I think it's just the semantics and how it's submitted. But I typically wouldn't think an EGC would be running through there. Remembering that the equipment grounding conductor is on the load side of an overcurrent protected device, and we size that EGC based on the size of the overcurrent device in accordance with 250.122. So probably just utilizing words, but to answer his question, yes. If you did run the equipment grounding conductor through there with the neutral conductor, knowing how they connect in the panel, that would be objectionable current. It would be something that would be potential. Now, the thing about that is, I don't know initially whether or not we classify that as an objectionable current, but we classify that as parallel paths for neutral current, and that conductor wouldn't be sized adequate. Okay. So that becomes another issue again with the neutral current, how it divides up. So many things to look at it, but we'll just go with objectionable current since we haven't really defined it. Okay. It says here, however, I believe that a grounding electrode conductor, okay, that originates at an outdoor ground rod, okay, so I guess it's a ground rod outside, is pulled through the service raceway. So it comes from the ground rod up, let's say, through the meter, in the meter, through the raceway, into the panel, okay, and terminates on the neutral bar in the service panel is acceptable as long as the GEC is bonded to both ends of the service raceway. Okay, so the thing about that is that in the way you describe it, in that installations, whether it's bonded on each end, it's still creating parallel paths for neutral current because of the nature of that raceway, in this case, say a nipple, and how it's connected, and it's connected to the enclosure, and it's probably got a supply side bonding jumper to it. And so the nature of all of this, or maybe it's a punched hole and they're using a lock nut that digs in, or whatever they're meeting the rules of 250.90 and 92. Whatever that may be, if you run another conductor through that and it intimately is connected at both ends to that raceway, but also connected obviously to the grounded conductor in the service equipment, then again, you're essentially doing the same thing that you said that you could do, that you couldn't do with an equipment grounded conductor, right? You just didn't really say where that equipment grounded conductor goes once it gets on the other side, inside of the meter, that type of thing. So theoretically, and it gets done all the time, that creates the same condition, right? Doesn't change anything. Okay. Let's see. What I frequently see and believe is incorrect is when a contractor terminates a grounding electroconductor coming from the supplemental ground rod outside. Okay, so he's got two ground rods. The first ground rod is the requirement per the code. If it doesn't meet 25 ohms or less, you have to supplement it, and he's using another ground rod. So that is the supplemental ground rod to the actual ground rod, which they work together in the grounding electrode system. But he's talking about when the GEC comes from the supplemental ground rod outside at a two-terminal lug next to the neutral service neutral at the meter pedestal. I'm not. This is an example where I can't visualize what you're asking, so I apologize. It's tough. Somebody out there might say, I get what he's saying. I'm not visualizing whatever. But anyway, there's two terminal lug out there. So I'm assuming that out at the panel, there is a common terminal block that's been installed, and that's what he's taking his supplemental to. Okay, let me read a little bit further here. Two terminal lug next to the service neutral at the meter pedestal. In the open second terminal, they will terminate a separate EGC bonding conductor that passes through the service raceway. Okay, so I'm not sure here why you would say it's an equipment grounded conductor. I don't know why that would be going through there. That's only on the load side of a service of an overcurrent protected device. So I'm not sure why you would be doing that anyway. What's the purpose? I don't know the purpose. I don't know. It's terminology is key here. So I'm not understanding why you would have the EGC going through there. Okay. But let's say when you say bonding conductor, let's say that we have, for whatever reason, you have, maybe we're doing this terminal block. Maybe this block is actually being utilized for inter-system bonding connections. And maybe it's the one that's used for that. And that's what you're talking about. And so I can only assume that. So 250.94, obviously you're not using A because that's only intersystem bonding devices, and that wouldn't be for this application. That's for communication. So I'm assuming you're talking about B, which is other means, which means you can have connection to an aluminum or copper bus bar, not less than 1/4 inch by 2 inches, and is sufficient length to accommodate at least 3 terminations for communication systems, in addition to other connections. So maybe that's what you're doing. I'm not 100% sure. But even if that was the case and you're running that conductor out there to extend it, if you're running it through the same raceway as the service conductors, again, you're creating potentially parallels, except for where it's making a connection to. And it's going through the raceway, so it makes it a one connection, but then the other end, it's going through and coming down and stopping at a terminal bus. So it's not making a connection to the metal meter. It's just passing through and down. Chances are it's going to make contact at some point with that meter. And so it's going to make a connection. And of course, that meter enclosure out there, typically the neutral bonds that meter because it's permitted in the code to do that. On the supply side, you can bind all metal parts with your neutral or grounded conductor. So again, typically you have the potential to create parallel paths for neutral current and create objectionable current based on that installation as you're describing the installation. Okay, anyway, it says the GEC is no longer continuous, and in my opinion, the conductor being pulled through the service raceway needs to go. I'm interested in hearing your thoughts. Thank you for your time. Okay, so here's a couple things. The grounding electrode conductor, let me just kind of get these out of the way. The grounding electrode conductor is required to be continuous. There are some ways you can splice it, irreversible, and there's rules in there, but typically that is unbroken to the grounding electrode. And in this case, it'd be the first ground rod. The second ground rod that's being installed is a supplement to the first. And the code tells me where I can make that connection for that supplemental electrode. And if you go look at 250.53, you're going to see that there's an A2. And the A2 says a single rod, pipe, or plate electrode shall be supplemented by an additional electrode of the type specified in 250.52 A2 through A8. Well, in this case, he wants to use a ground rod again. Okay, but that's what he did. So it says the supplemental electrode, which is that second rod, shall be permitted to be bonded to one of the following. Number one, it can connect to the other rod, which is typically how we do it. Now, that does not have to be continuous from the first rod, from the panel to the first rod to the second rod, because the grounding electrode conductor unbroken rule is to the first rod. This is a supplemental ground rod. So it sounds like the installer's choosing not to go back to the first rod. He's going to another location, which is at the meter. So let's see if that's permitted. It says, all right, so number one, it can go the supplemental, and let's say just 6 copper going from the second ground rod to the other ground rod is permitted. Number two, it says it can go to the grounding electrode conductor. Okay. So that sounds like what it might be doing if it's going to the grounding electrode conductor that's, in this case, running through the raceway and then down to a terminal block. Well, that is the grounding electrode conductor, and you're making a termination to it. Okay. That's okay. Again, I'm not going to talk about the fact that it shouldn't run through the raceway with the service conductors because of the nature of how these connections are made and the intimacy of how that conductor runs through the meter and the meter being metal and whatnot. But anyway, we're talking about the supplemental. It's making connection. So if it's making a connection to the grounding electrode conductor, then it's good. Doesn't have to go to the other ground rod. The third way is it can make a connection to the grounded service entrance conductor directly, and it can make a connection to the neutral, which is the grounded conductor. And in this case, since it sounds like it's a dwelling, it's going to be grounded conductor is also going to be the neutral. Not always the case, okay, in some commercial applications, things like that, but residential usually is the case. The next would be a non-flexible grounded service raceway. So if the raceway is coming up and it's going into the meter and the meter's bonded properly, which is typically going to be to the ground, to the neutral, then if you have a non-flexible, let's say rigid, intermediate, EMT, whatever, then I could take that second supplemental and I could take it to that and put a clamp on that and connect it there. That would be fine. And then the last one says any grounded service enclosure. So this is one of those examples also where people get really confused when it comes to the grounding electrodes and the grounding electrode conductors. I have to go from the grounded terminal bus and go to the grounding electrode. But the supplemental does not. It can go to any one of these 5 locations. And of course, we have the exception that says, look, if that single rod that you're talking about is 25 ohms or less, then this supplemental one we're discussing is not required. It wouldn't be needed, wouldn't be necessary. Sounds like in this example, nobody has those expensive, ground resistance meters. And you could get the 3-point, 4-point fall of potential ones, but then you got to have enough room to do that on the property. And, in most cases, not practical. And the clamp-on ones are really expensive. It's just much easier to drive another ground rod as long as you got the space to do it. So at the end of the day, it sounds like, that at least his connection to the grounding electrode conductor, based on how your question was written, was acceptable. That does not have to be continuous, by the way. But the one to the first rod would have to be, unless it meets some of the allowances in there for it to be spliced. Again, irreversible, crimp, things like that. So you have some allowances in there. But typically, that supplemental one is not going to be an issue. Okay? So, trying to get back to this question. There's a lot in this question. The 2 terminal lugs outside, I'm not sure what those are, unless, of course, those are allowing it to make connection to grounded service entrance conductors. No. It sounds like to me it's making connection to the grounding electrode conductor. Because the meter enclosure itself, it says any grounded service enclosure. That's not a service enclosure. It's a meter enclosure. But anyway, you've had the different options to do that. It sounds like they're using one of those options. The only problem that you could have, again, and this has been argued by many people, is that anytime you go from a meter into the back of a panel, and even though now you're required to have an emergency disconnect outside, and so what happens in that is if you did have an emergency disconnect outside and now you're going to be feeder conductors going in, then those would be feeders and you were separating everything downstream anyway. If that outside emergency disconnect is also your service disconnect, then you have options under 230.85 for that not to be your service disconnect. Obviously, there's 3 options there, 3 ways you can go. But at any rate, if it was a feeder at that point, then you're required to separate everything downstream anyway, so you're not going to have any objectionable current issue. In this case, we're talking about a traditional application before you had the requirement for a emergency disconnect for 1 and 2 family dwellings. This is just a meter outside and a panel inside. And if you run a metal nipple between the two and you bond it like you're supposed to in the code, and you put your main bonding jumper inside of the service equipment as you're required, 250 to 24. If you do all that, then you're going to have parallel paths based on the metal raceway between the meter and the service, as well as the neutral that passes through. It's just there. The only way around that is to put in a PVC connection between the two. The code is not mandating that, although people out there will say, well, because you're required to install it so that you don't have objectionable current, that it forces you to use it. Okay, well, whatever you feel like, whatever your local jurisdiction wants to do, I can tell you that a vast majority of installations use metal nipples, metal raceways between. And to be honest with you, if you bond it all right, you do everything right, what you've got is everything at the same potential, so you don't have the hazard. Okay, so you're trying to put everything, your bonding rules, everything on the supply side, the allowances that the code lets you do, you're putting everything in it. Does it still mean that you could have objectionable currents? Yes, but that is very limited on the supply side and not to be done on the load side, right? Because we have rules for the load side. It's the supply side. In a perfect world, tell everybody to do it in PVC. You don't have to worry about it. However, if you did it in PVC and you did it as you described and you ran a bare conductor through there, and then you ran your neutral and you made that connection on the load through the nipple into the meter, and it made connection to that bare that you're running through there, whether it's the grounding electroconductor you're sleeving through there or whatnot, then what you'll end up having is, again, an issue of parallel paths and a potential for objectionable current. So you're introducing that. So the way that you would prevent that is just don't take the grounding electroconductor through that raceway. Take it out of the panel and punch its own hole and take it out. What's the point? So some people will argue that that's the whole nature of telling you that you have to do it so that you don't create objectionable currents. So just don't take it through that service nipple, right? And that seems plausible to me. And I never did that, by the way. I always came out of my panels, came down through the hole they provide, and I poked through, and I went out as close as I can to the ground. And that's how I made my connections. But everybody, entitled to their own way to do it. But it's the best I can dissect your question. It's a long one, and maybe you follow up with a little more details. But yes, if I had to read the code again, let's kind of look at 250.6. And let's look at where it says that I can make alterations to stop objectionable current. It says, all right, let's read them both. Let's look at A again. It says arrangement to prevent objectionable current. It says the grounding of electrical systems, circuit conductors, surge arresters, surge protective devices, and conductive non-current carrying metal parts of equipment shall be installed and arranged in a manner that will prevent objectionable current. Okay. We haven't defined it, but we kind of know that creates unintended paths for current to flow. In some cases, we encourage it in the code. That's why we can't define it. But in this case, we're trying to not encourage it. And then it tells us that we can make alterations. And alterations to stop objectionable current. It says, if the use of multiple grounding connections results in objectionable current. Now, here's the thing. It has to result in objectionable current. So what is the issue that it's causing for you? If on the supply side, I'm bonding everything together and we're reducing touch potential from different metal parts, then, we're making an effort to create and make it as safe as it can be. You can never make everything 100% safe, but we're doing it. So what effects is the objectionable current having? A couple things we got to remember anyway is that there's no overcurrent protection device on the supply side. We only have overload protection based on the overcurrent device that's inside the panel. So we're going to limit the current on those service conductors based on whatever that rating is. I get that. But there's no short circuit or ground fault protection on the supply side. And we don't know what's up at the transformer. We don't know where their fuses are. We have no idea. So we're not going to worry about that. That's them. That's not us. Okay, as an electrician, we can't concern ourselves with that. So when it comes to objectionable current, it's much more of a hazard for us to equate with as electricians on the load side. And the code gives us good rules on what not to do on the load side, improper case to neutrals. You get me? But on the supply side, it's very difficult. So this is why we've traditionally accepted if somebody ran a metal nipple between a meter and a panel, and obviously the neutral conductor goes through there. And because of the nature of the connections, you're creating parallel paths for that current. But remember that the impedance is much lower in the neutral than it is on the raceway. So at the end of the day, the vast majority of current, even though it takes all available paths, will take the path proportionally to the amount of resistance, or in this case, AC impedance in that path. So the intended path will be achieved. The problem you can have is if you lose your neutral and then you have other problems that take place. But again, at the end of the day, we have to install systems based on what we got. Right? We can't overtly predict what could happen. So at the end of the day, that's been a common accepted practice. Now, what I wouldn't want to do is put a PVC nipple between it and then run another conductive material like a grounding electroconductor through there, which makes the same connections on the bus as the grounding conductor in the service equipment. Now I'm running both of those through. And then if you do as you say and you bond one end of the Raceway with that grounding electroconductor, because we're not talking about a supply side bonding jumper here, we're talking about using that GEC as you noted. If we did that, then we're basically creating parallel paths, and that would be encouraging objectionable current. So with the nipple, with the metal, it's something that we just do. And the code, unless somebody submits a public input that requires PVC to be utilized, we're not going to get rid of this practice. I don't know how you would get rid of this practice. If you're using a metal nipple, it's there. How you can meet this part is if you do something like use a PVC nipple, but then you run a grounding electroconductor, then you're incorporating parallel paths that you could have done something otherwise. You could have run it out of the panel and out of its own hole and not done that. So you need to avoid doing that. And that's what I believe that the code is trying to say in 250.6a. That's what I'm saying. If you have a metal Raceway and you've got your service conductors in there and you run a grounding electroconductor through there because it's just convenient, you only want to make one hole in the building going out of it, I get it. But now you're incorporating something that you can control, and I believe that you should avoid doing that and take it out its own hole. That's what I believe. Okay? So I don't want to sound like a hypocrite when it says, well, Paul, you're okay for the metal nipple, but then you're not okay for the run the grounding. Look, you trust me. Code Making Panel 5 understands, and I'm not going to speak for the panel, but we understand that that's a practice that's done in the industry with metal Raceways on the supply side between the meter and the panel. We get it. We get it. And because of the nature of the bonding and what you're allowed to do, the best we can hope for is that everything is at the same potential, and we've reduced touch potentials, knowing that we have no overcurrent protected device that we can control at the transformer. That's the best we can do. Other than the code requiring it to be PVC. And of course, some people will read this and say that I am, as a jurisdiction, requiring the use of PVC in accordance with 250.6a because of what this says, and I need you to run PVC. And you know what? If that's your jurisdiction and that's what you want to do, go for it. That's totally up to you. But I can tell you right now, the majority of commercial applications have metal nipples between the service equipment and the meter enclosures or CTs or whatever they got. So I'm telling you, that's just, it is what it is. Like it or not, it is what it is. Incorporating anything else into that Raceway creates a real known issue with objectionable current that was avoidable. It means you could have avoided it. So when it comes to avoiding or stopping objectionable currents, assuming one has been identified as objectionable current, whatever the definition of that is, it says, if the use of multiple grounding connections results in objectionable current and the requirements of 250.4A5 or B4, so A is going to be in the grounded systems and B is going to be ungrounded systems, it says, are met, one or more of the following alterations shall be permitted. Okay, so number one says, disconnect one or more, but not all of the grounding connections. Okay, so I could if I've identified objectionable current, then I could not take the grounding electroconductor through that Raceway. If that will eliminate, that's probably going to get rid of all of them because of the metal. But if you did run PVC and you did stick a grounding electroconductor through there because it was convenient and you had objectionable currents, then you could remove that and take it out of the panel as you normally would out of its own hole, out of the building, drill a hole and run it. And that would alleviate that issue. Okay. Number two, change the location of the grounding connection. Again, same concept. Instead of running it through there, run it another path. Find another way to do it to remove the issue of the objectionable current that's been identified. Number three, interrupt the continuity of the conductor or conductive path causing the objectionable current. So whichever path is doing so, remove that path. Now remember, we cannot do anything that's going to lessen the safety of the system. Okay, we can't remove, bonding jumpers that are necessary in order to clear overcurrent devices, let's say with the main bonding jumper or anything. We can't remove something that's going to make the system unsafe. But I can tell you that taking the grounding electrode conductor through there, if that's your issue, then reroute it another way. And that will remove the application and remove the condition. And number 4, it says, take other suitable remedial and approved actions. And again, approved actions are going to be discuss it with your local AHJ and let them understand the conditions that we're dealing with. But again, I am not aware of any AHJ that has a problem with a metal nipple between the meter and the service equipment, even though we know tongue-in-cheek what's going on. But they do have a problem when you run an additional conductor like a bare grounding electrode conductor through that raceway with service conductors. Now, I've seen it in pictures, and in other locations, they don't have a problem with it. They don't. And in other places, they have a big problem with it. So again, work with your local AHJ, and you know what? There you go. Now, what is not considered, or what currents are not considered objectionable current? That's where we look at C, and it's just important to note. It says temporary currents not classified as objectionable currents. Temporary currents resulting from abnormal conditions, such as a ground fault, shall not be classified as objectionable currents for the purpose of as specified in 250.6a and b. So again, any current that would be placed on a system, even if it's just for temporary, like a ground fault, that's not called objectionable current. So people will say, well, you can't have this conductor here because in a ground fault, it creates current on there temporarily, and that's now considered objectionable current. No, we're going to, any of your non-current carrying metal parts, if installed right, should not carry current on the load side. Okay? Only in a ground fault condition. So or it can carry it in a where one conductor might short to the metal raceway, which provides an effective low impedance ground fault current path back and hopefully clears an overcurrent device very quickly, right? An improper case to neutral connection downstream puts current on the metal parts constantly because we know we have, alternating current, and we know that all loads aren't balanced, and we know that we're going to have current traveling on the neutral at any given time. So you don't want to downstream connect it to the metal parts because then you'll have what's called circulating currents in the system, and that is an objectionable current. But what we're talking about is any ground fault is an example that gets placed on these metal parts due to a certain condition, ground fault condition, that current that's traveling on those parts, that is not considered objectionable current, and it's temporary. It's only there until the device clears, which is very quickly, inverse time breakers. Again, inversely proportional. The higher the current, the greater the low impedance path back to the source means that the current will get very high at the point of the fault, and that means that it will trip the breaker very quickly. So again, that's not objectionable current. All right, now, D goes on to tell us, and again, for those that are following along, I'm in 250.6. D tells there are limitations to permissible alterations. And basically, that's basically saying, look, this section shall not be considered as permitting electronic equipment to be operated on AC systems or branch circuits that are not connected to an equipment grounding conductor as required by this article. Currents that introduce electromagnetic interference or data errors in electronic equipment shall not be considered ejectable current addressed in this section. So we're not talking about the noise. Okay, we're not talking about interference. There's applications where people run an isolated ground, and the isolated ground is for that piece of equipment, but you can't circumvent the requirement for the equipment ground in bonding the metal parts. That has to take place. But that equipment that allows for an isolated ground has its own path for that isolated ground, but it's not to circumvent the fact that you still have to clear an overcurrent device that's supplying power to that piece of equipment. Okay. And again, this has nothing to do with electromagnetic interference, or data errors on electronic equipment. Okay, that's not what we're talking about here. Okay, for the alterations, to be able to make an alteration. Okay. All right, so that's pretty much, I don't know that I covered this, this entire topic adequately. I tried to answer your questions and give you a lot of stuff to think about. Other people can agree to disagree, but that is the gist of what I can give you based on the reading of this long question. And that's, if there's something I need to follow up, please feel free to go to paulabernathy.com and submit a follow-up and more clarification on what you're asking, and I will do my best to try to do that. Until next time, folks, stay safe. God bless.